How did the moon get to be like it is? And why is it so different from Earth in terms of the fields that it has? Join us as we discuss how the moon's magnetic field disappeared a billion years ago, and a study just discovered why. If you were to try and list all the things that are important to the Earth that are outside of the Earth itself, the two top things you'd likely list are the sun and the moon. Both the sun and the moon play a big part of what's going on in our world. From the heat that we get to the light that we see both in the day and in the nighttime, and their gravities both keep us in a stable orbit and affect things like our oceans in a fair way. But as we continue to look at the moon and the sun, we continue to wonder how they came to be and what changes they had over the years. Now, a recent study has shown that not unlike the Earth, the moon once had a very strong magnetic field once upon a time, but around a billion years ago it basically disappeared. How is that possible that we know this? Moon rocks. Some of the rocks that we had gotten from the moon were formed via impacts, probably from meteors or even asteroids, albeit small ones. And when these impacts formed new rocks, they gave a snapshot of the magnetic field to the rocks themselves via the grains inside them. It's complicated, but it's science. Anyway, by examining these rocks, it was found out that about a billion years ago, the magnetic field of the moon dropped from a very strong entity to only 0.1 microteslas, around 500 times weaker than the Earth's today, which is a significant drop no matter which way you choose to look at it. But how is it possible that the magnetic field of the moon had dropped like that a billion years ago? That would be the dynamo that was powering the field itself, or in other words, the liquid core of the moon. A liquid core is needed to make an electromagnetic field, and while the moon did have one at one time, by the point of a million years ago, it had cooled and crystallized, or so we speculate, and due to that, the field diminished in power by a large margin. A strong field on the moon may have shielded the surface from the solar wind, the supersonic plasma emitted from the sun. Planetary scientist Benjamin Weiss of the Massachusetts Institute of Technology told Newsweek. He went on to note this may have prevented the surface from being space-weathered and the soil becoming rich in solar gases like it is today. So basically, how the moon looks right now may be directly tied to the loss of its magnetic field, which if that sounds familiar, that would be because it's the same thing that happened to Mars. The red planet once had a powerful atmosphere and magnetic field, but eventually that changed, and now Mars does not have an intrinsic global magnetic field. However, it does have a magnetosphere due to interactions with solar winds. But that's not enough to keep a lot of the solar radiation from bombarding the planet, and thus making the atmosphere even more unstable. As a result, Mars looks like it does right now, and that might have been what happened to the moon once its core cooled down. Scientists also point out that when the magnetic field of the moon was up, it might have been closer to the Earth. Furthermore, the moon was likely about twice as close to the Earth during the time the moon was inferred to have a strong magnetic field compared with today. This would be a very interesting twist on the history of our planet, because as you hopefully know, the moon drastically affects things on Earth, including the gravity it exerts on the planet's oceans. So if it was twice as close as it is now about a billion years ago, that would mean that the Earth has gone through some serious tidal shifts because of the placement of the moon. Not to mention, this would further show how the moon is drifting away from the planet. The gravity of the two massive objects do seem to imply that they are in a locked formation with one another, but that's actually not true. The forces are slowly pushing them apart, and so every year the moon gets 1 inch away from Earth. Granted, that's not a lot of movement over a lot of time, as it would be over a decade before it would be another foot away. But eventually that will affect the Earth in a significant manner. Getting back to the magnetic field issue, what might surprise you is that scientists think about 4 billion years ago that the magnetic field of the moon was about 100 microteslas. That would make it twice as powerful as Earth's. This belief came also via moon rocks, but whereas the ones that were mentioned before were born via impacts, these ones were done via natural volcanic eruptions, as the tiny grains within them aligned with the magnetic field. They gave a snapshot of being much more powerful in regards to the field than previously anticipated. Granted, this is not an exact science, and those studying this will fully admit to you that there are gaps in the chronology of moon rocks. The past 3 billion years of lunar history has been a mystery because there's almost no rock record of it, Professor Weiss told Newsweek. However, recent discoveries, including ones found in 2017, showed that there were still some rocks from billions of years prior, including a set from 2.5 billion years ago. That showed at that point in time the magnetic field of the moon was at about 10 microteslas, which, if you've been keeping track of what we've been putting out in terms of numbers, means that between 4 billion years ago and 2.5 billion years ago, the magnetic field of the moon was diminished by the power of 10, and then between 2.5 billion and 1 billion years ago, it went down by a factor of 100. That's an incredible drop, and one that further cements the notion of the dynamo being cooled off and thus causing the power of the field to plummet. But the reason for the cooling is still being discussed, especially since many are curious as to how the dynamo that created the field was born in the first place. As stated, a liquid core is required for such a magnetic field, and many think that when the moon was created, we'll get to that in a bit, its proximity to the Earth caused the various metals in the liquid core to be stirred, and thus the field was born, and was rather intense. Then, as the Earth and the moon began to drift apart from one another, the core started to cool off slowly, and caused the crystallization. But this didn't stop the magnetic field, rather the crystallization process itself caused the metals to continue to stir, and as a result the magnetic field lived until the core became fully cooled off. The magnetic field is this nebulous thing that pervades space, like an invisible force field, Professor Weiss said. We've shown that the dynamo that produced the moon's magnetic field died somewhere between 1.5 and 1 billion years ago. Yet there are still some mysteries as to why it cooled off so quickly in the terms of billions of years and why it didn't last longer. The size of the moon is believed to be one of the factors. This is because the moon is a small planetary body, such that it cooled off much more quickly than planets do, he said. Mars has a diameter about twice that of the moon, and yet it is widely thought that Mars's dynamo ended about 4 billion years ago. The moon's dynamo must have had an unusually long-lived power source. The study of the magnetic field is continuing on and will continue to be studied to see just how the moon came to be how it is right now. We are now trying to see if we can measure the direction of the ancient field using Apollo samples, whose original orientations we can construct, Professor Weiss told Newsweek. So where does that leave us? Well, honestly, with many questions and only a few answers, and I'm not trying to be vague in that statement. It's very true. There are a lot of questions about how the moon came to be and how it is right now, so it's only logical that this new fact about the magnetic field only adds to the mystery of it all. Formation of the universe is by and large one of the biggest and most important mysteries in all the world today. There are many explanations for what could have happened, or even what might have happened, but do we know what happened? No, we don't. And that brings us to the moon. Because obviously the moon is out there, and obviously it has a big impact on our planet. But how it got up there, so close and yet far enough to help us, is still a bit of a pickle to discern. As of right now, there is one major theory that most scientists feel is the right answer in regards to the moon's birth. It's called the giant impact theory. To put it basically, when the solar system was being formed, a bunch of celestial objects were being made. Planets, moons, asteroids, comets, that kind of thing. But unlike the solar system we have now, not everything was tethered down just yet, which meant a lot of pieces were sent flying into the vast reaches of space. One of these bodies is believed to have been about the size of Mars, and it got thrown into, or just plain collided with the Earth. When the young Earth and this rogue body collided, the energy involved was 100 million times larger than that much later event believed to have wiped out the dinosaurs. Despite the impressive explosive yield that this impact would have brought, it didn't wipe out the Earth. Far from it. It merely jettisoned some parts of the Earth back into space. But because of the Earth's gravity, they stayed relatively close to one another. So after another couple million years, the moon was formed, and it eventually became locked to the Earth as we know it now. And there are many who believe this for very basic reasons. One of which is that after we went to the moon via the Apollo missions and got a bunch of moon rocks, we found out that the composition of the moon and the Earth are very similar. Incredibly similar, in fact. Now, sure, there are other logical explanations for this, including that the stuff that made the Earth and moon were from the same pool of rocks, and so on and so forth. Many think, though, that the near-identical natures of some of the elements prove that the moon came from the Earth, which would give us an even greater connection to it than we had before. Why is this important to dissect? Because that would lend credence to the notion that the moon's core was stirred up by the Earth because of its proximity. Because if the asteroid mentioned in this theory was the cause of the moon's creation via millions of years of rocks and such being pulled together and the like, that would mean that it had to be close enough to the Earth to be formed that way. And thus the gravity of the Earth got the core to stay liquefied and thus caused the magnetic field to form in a very strong way. Going forward though, does the lack of a magnetic field matter to us here on Earth? Absolutely. Because despite a lot of people looking to Mars as the next great place for humanity to colonize, there are many who still feel that we need to go to the moon first. So much so that many major power players, including the head of Amazon and the Vice President of the United States, are trying to reignite the spark of going to the moon and putting colonies there. And with no magnetic field around the moon, living there is going to be that much harder. Because as we noted near the beginning of the video, a magnetic field helps deflect, block, and sometimes even absorb radiation from the sun, so that the planet itself isn't bombarded with it. And thus, if we were to colonize the moon, we would have to make sure that our suits and any areas that we lived in would be protected from said radiation. Thankfully, we've already done half of that battle with the suits and the ships via the Apollo missions. But we haven't done that yet in regards to a massive colony that would potentially house hundreds, if not thousands of people. And no, the International Space Station doesn't count there. Granted, that doesn't mean living on the moon is impossible, but it raises a lot of problems, including many that Mars has. The ground is barren, and thus can't produce things like plants, which means we'd have to do that ourselves. There is water on the moon, but not enough to sustain us very long. And with the threat of cosmic radiation, we'd have to make sure we're protected at all times. So learning more about the history of the moon is quite important, because it can lead us to being prepared for when we might live upon it.